Hey everybody, welcome to 4-6, fundamental theorem of algebra. Basically, I gotta be honest, this is not anything really new, at least when you were in class. I know for a fact I've mentioned it. I may not have mentioned it in other videos. But this is 4.6. I'm probably gonna cut this into 2 videos because I cut this into 2 lessons. So we'll get there. So fundamental theorem of algebra says the degree of the polynomial is the number of solutions. Degree is your highest exponent. So whatever your polynomial is, whatever your highest exponent is, that's your number of solutions, both real and imaginary. And obviously, I made the joke that we were going to put the fun in fundamental theorem of algebra. That's why that is underlined. You're going to use synthetic division and the quadratic formula to find all the rational zeros of the function. So quick recap. X to the fourth looks something like this, and that's because we have 1, 2, 3, 4 places that we're crossing the x-axis. Well, we're going to come up with a couple scenarios where this being one of them, and forgive my drawing, I'm so sorry. This being one of them where I have here and I have here. I'm looking for 4 solutions and I only see 2. Well, that's because when it comes up and touches, or some teachers call it a bounce, when it bounces this line or touches and bounces off this line, we can actually count this solution and this solution twice. So this counts as 2 and this counts as 2. That's how we get our 4. We will also get to something like this, where I have 1 solution here and 1 solution here. And okay, this is not a solution. This is not the axis we're trying to cross. So this is not a solution. So what we're going to do actually is try to find the imaginary. So we have this imaginary line that we would kind of sort of potentially cross, and we're trying to find some imaginary solutions. That way we can have 2 real and 2 imaginary. That's how we get our 4. So we're going to kind of tackle all of these as we get here. So examples 1 and 2 are kind of the thing we've been talking about. How many solutions does this have? How many zeros does this have? Usually, not always, I don't want to say always, but usually they'll ask for solutions if they have set it equal to 0, and they'll ask for the zeros if they've set it equal to f of x or y or whatever. They're asking the same thing. How many answers am I going to get? Well, x to the 4th means I'm going to have 4 answers. I don't have to worry about this at all. It's not going to be 4 and 2 more or anything like that. Highest exponent and only highest exponent tells you how many answers. So down here, x to the 3rd, x squared, and x. I don't care about the 2 and the 1. X to the 3rd means I'm going to have 3 answers. So find all the zeros of the polynomial function. Actually, I'm going to pause real quick because you need a calculator. So what I told my students is, first things first, we'll go into y equals, and oh my goodness, I'm on the wrong one. Let's save it. Of course, it kind of won't. I'm going back. I'm so sorry. It's the same concept. You'll get the idea. So we go to the graph, and oh no, my statistics activity's there. Hold on. I'm so sorry. If I had better video editing stuff, I would have totally cut out that last segment. I'm really sorry. So we're going to go into y equals, and if you notice, I just switched back to the regular calculator. And we're going to type in what we see. Once we do this, keep going. There we go. You can go to the graph and kind of see what's happening. Sorry about that. So when we press the graph, once we type it in, press the graph button, especially on these calculators, it's really tough to see what's happening here. So if you hit second and then graph, we go to the table. The table is going to be so much more helpful, because what we are looking for in the table is anywhere where y equals 0. So we actually have 2 of my solutions right here. Well, how do we get the 3rd one? Well, that's what these steps are for down here. Use the graph to find some answers, and then we're going to do some synthetic division. And basically, whatever's left is going to help us find it. So here we go. Minimize that. Graph told me -3 and -2 were both answers. And so 1, 7, 16, 12, we're going to use some synthetic division. Now, I want to point out, we're going to use -3. And my students were like, whoa. With synthetic division, I thought we were supposed to change the signs. I said, absolutely. If it looks like this, we always had x plus 3, we changed the sign. But like if you solve this to get x by itself, they virtually have changed the sign for us. And so it made sense to them. So, okay, it might have been just one of those, this is a little bit different, just go with it. But bring down the 1, multiply, combine, multiply, combine, multiply, and you better get a remainder of 0. Calculator said this is for sure an answer. This better be 0. So then we'll use what got left over, excluding the remainder. We'll do synthetic division again, but this time with the -2 or the -2 answer. Bring down the 1, multiply, combine. If you need some synthetic division help, there is a previous video that has step-by-step synthetic division. So you may want to go review that if you're having issues. But anyway, when we're done here, I had a 1 and I had a 2, remainder 0, which is good. Building back up, constant x squared, which I did here, constant x squared. This is just x plus 2. And to find my last answer, I just set what got left equal to 0, which means actually -2 got used twice. So if you zoom in really close, and actually let me show you. Zoom in, you can see, oh no, let me change this real quick to like a -5. You can really see it goes just above, touches here, and that's why -2 got used twice, because it goes just above, touches, and then goes back up. Remember, any touch we actually see as 2 answers. Here's the next example. Ignore some of the answers because we plug this in the calculator. We go to the table. Surprise, surprise, it gives us 2 answers where x is -1 and y is 0, x equals 1 and y is 0. So we can do synthetic division with these two. That's not too bad. And we get stuck here where I drew this little yellow line. This is kind of where I stopped day 1 because we're going to have to do this a little bit different. But since we're only 7 minutes into this, I think I can finish this problem. So the graph itself, and here, let me show you what the graph looks like. Graph looks like this, and we are looking for 5 answers, and we see 1, 2, but we're not totally sure if that counts or not. We go to the table, and this is really where, because the graph doesn't always tell us. Maybe it crossed at 1 and then crossed at like some crazy decimal just past 1, and we can't really see it. This is what we know so far. So when we are stuck with x to the 3rd and we don't know this answer yet, well, there's a really good chance we have a bounce right here. And so 1 should probably get repeated. One of these answers that you have seen in the table is probably a bounce answer. And so we can use it twice. Well, obviously, we know 1 works, but how do we know -1 didn't work? Well, if you use these numbers for synthetic division with -1, you get a remainder. Remainder means this, that's why there's big X here. This is not a solution. -1 does not work. So I'm going to use the 1, -3, 6, -4, and I'm going to try it with +1. See how they're the same, and they both came from this blue right here? I have a remainder of 0. So that's why this 1 is this answer right here. So now we're stuck here. X squared minus 2x plus 4. Well, let's try to factor it. How can I multiply to 4 and add or subtract to -2? Well, 4 is either 2 times 2, which would add to 4. Nope. Subtract to 0. Nope. And -2 and -2, same thing. 4 times 1. Well, that would add to 5, or -5 potentially. Subtracts to either 3 or -3. Neither one of these work. Well, you did see up there we have a couple imaginary answers. So we're going to actually take this and go to everything's favorite thing in the world, quadratic formula. And I will say right here, if you're like, I've never done this before, scroll back up through the playlist where it says quadratic formula and watch those videos. Okay, so if you're still here, I assume you have a vague idea of what's happening here, or you went and watched the videos, so welcome back. We are plugging in x equals negative b, so positive 2, since it's b is negative 2, so the negative b, plus or minus the square root of negative 2 squared minus 4 times 1 times 4. This highlighted part, if you remember, is called the discriminant. That by itself changes to negative 12, and this negative should tell us we have an imaginary answer. So I started building it over here. I'm going to have x equals plus or minus imaginary. Excuse me. And I know the 2 still goes in front and the 2 still goes on bottom. We're only messing with this. Well, now that I've taken out that, I can factor out 12. 12 divided by 2 is 6. Divided by 2 is 3. There's my last prime number. Well, I have a pair of 2's, so that's going to come outside of the square root, and this little guy, he's going to stay inside. So we're here. Now, 2, 2, and 2 are highlighted because if those 3 spots have something in common that you could take out and divide by the same number, then you do it. So divide them all by 2. 2 becomes 1. 2 becomes the invisible 1 that we don't have to write. And 2 becomes an understood divide by 1 that doesn't need to be there. So 1 plus or minus I square root 3, which is why up here I did the 1 plus and then the 1 minus on my 2. So there are my 5 answers. Whew, that was tough. But video 2 has some more examples that we'll just kind of go a little bit faster and it won't be terribly bad.